Okay, let's move on to the next section. And I found the number of section number are incorrect. It's correct in the book, but incorrect in the slide. I need to modify. It's section 3.2 here. 3.2, PPP. Okay, PPP is a point-to-point protocol, and it's derived from the HDLC. HDLC is an old protocol. And within PPP, you will see several other protocol components, which is called LCP and IPCP. And LCP is for connection setup, the session setup, to set up the session. And IPCP is actually to transfer the data. So in PPP, you need to do the authentication first. You need to log in first. And then after you log in with the LCP, you start to transfer data with the IPCP. So that's the basic idea. And then you would have PPP OE because at home you might, or a small office, you might have multiple stations sharing the same DSL link. Then you would need IP over PPP, then over Ethernet. So your IP over PPP, then over Ethernet. So you would need a PPP OE over Ethernet. So this is kind of protocol family that HDLC is HDLC evolved into PPP, but in the process, in the evolution process, it was much simplified. As I mentioned, that PPP has removed the flow control, no acknowledgement, but still leave the CRC for error detection. Okay, so it's much simplified. And within PPP, you got LCP and NCP. LCP is to establish, configure, and test PPP's connections. And after this LCP is done, then you go to NCP to transfer the data. And NCP has some different protocol, and IPCP is one of them that handle the IP upper layer. If the upper layer is IP, then you would use IPCP. But if it's not, then you use another protocol under the NCP protocol tree. So reduced to you pay your attention to LCP and IPCP. Okay, and there's another evolution from PPP. That is PPOE. It's because there might be multiple stations sharing the PPP link. Okay, and those multiple stations, they reside on Ethernet. Okay, so then you need IP over PPP, then over Ethernet. So let's talk about HDLC first. It has this frame format with a flag. So it has 8-bit flag at the end, at the beginning, and also at the end. So HDLC would use bit stuffing. We mentioned byte stuffing and bit stuffing, and bit stuffing is actually used in HDLC. Okay. So if within the payload here, if the bit pattern of the start or end of the frame happen in the data in the payload, then you would need to do bit stuffing to destroy the pattern. Okay, and there's indeed an address even though it's a point-to-point link. And it says that it might happen that SDLC could be used for in a point-to-point link by multiple receiver with a master and a slave. With a master and a slave, then you will need address to probably not 8, but you will need to identify which slave to receive the frame. Okay, but you will see that in PPP, this address is fixed. They don't use they don't need to specify the address. And then control for error control or flow control will be used here, and also to specify what frame type it is. And then that's the actual payload appended with the FCS, which is CRC, the 16-bit CRC. Okay, when we move on to PPP, you will see the frame format is similar. However, they also use bit stuffing, the spatial bit pattern, bit stuffing to do framing. For framing, you still rely on bit stuffing. And the address is fixed. It's all 1, so it's not used at all. And the control field is fixed. It only to signal that this is PPP. This is PPP protocol. And okay, sorry. Only signal this is PPP protocol family. And then you use this field to signal what protocol it is for LCP, IPCP, and then the payload and frame check sequence. And the operation of PPP is as follow. You start from here, and then you try to build a link, bring up the link by carrier detection and user configuration. Okay, so you come to this state, and then you do the authentication by LCP. So you do the authentication here for LCP. That's step 2. No, sorry, LCP here. To establish here means the link level establishment. You exchange the link level parameter, and that's done by LCP to negotiate the link layer parameters. And then after that, you do authentication to log in. And then you use NCP, perhaps IPCP, to again configure. First of all, configure the network level parameters, network layer parameters, and then once done, you start to send data frames. Okay. So most of the time, you stay here. You stay here to exchange data frames, and after it's done, you decide to terminate. You go there, and then clean up the data structure. You go back to the original state. So you will see that here you use LCP, and here you use NCP to negotiate the link level and also network level layer parameters. And most of the time you stay here. After when you are transferring data frame, you stay here. And between this and this, between LCP and NCP, there's an authentication that does log in. You log in here, and that's the place that they make sure you are the subscriber. You are the paying subscriber. So one of the key reasons is, in addition to the link level and also the network level layer parameter negotiation, they need to make sure you are one of the paying customers, so that they can bill you, okay, monthly. And LCP, we mentioned that it has its protocol type value, and it also negotiates the link level parameters. Try to bring up the link by negotiating these, including the maximum receive units or maximum frame units, authentication protocol, compression. And NCP, one of the NCP, which is IPCP, it also negotiates the network level parameter. Basically, it would say compression if needed, and then the basic IP address. So the client needs to get the IP address through IPCP. So once this is done, then the data frame can proceed. Okay. And we mentioned PPP-oE. It would allow multiple stations on an Ethernet to open PPP sessions to multiple destinations through the bridging device. Then one question will be why PPP-oE instead of just IP over Ethernet? I could just use IP over Ethernet. That's the question when on campus, for example, you use IP over Ethernet in a wired environment. Why not just use it at home, the same architecture, IP over Ethernet at home? Then they would not be able to bill you individually, right? That's the problem. So they need to, even if your home is a small office, okay, if this is a small office and get to the internet by ADSL and running PPP over on top of it, then they still need to build it by PPP-oE, and they can do access control and billing in the same way as dial-up services using pure PPP. Okay, so the frame format will be PPP frame, Ethernet frame with PPP frame in the payload, and then within that PPP frame there's an IP packet in the payload. And PPP-oE just do one extra stage, okay. In addition to the original PPP session stage with LCP, IPCP, and then IP over PPP, it has one additional stage, which is discovery stage. They need to identify the MAC address, the Ethernet MAC address of the peer, of each other. They need to identify each other, who is holding which MAC address, and then establish a PPP-oE session ID. Then they can proceed to the next. So there's an discovery stage, because this PPP link is not by just two stations. At the customer side, this is not just one station. It's multiple stations connected by Ethernet. So you need a discovery stage to identify each of them. And then each of them would run through LCP, IPCP, and also in between LCP and IPCP, you have authentication to log in. Okay, open source implementation on PPP, it's in software, not in hardware. Remember in chapter 1 we mentioned that if a link protocol has some timing critical component inside, then that link protocol needs to be implemented in hardware. However, in the PPP protocol design, there's no critical operation, time critical operations. So it could be implemented in software, in the driver. Actually, it's implemented in the driver. And one tricky thing is that we just mentioned that HDLC and PPP, they use CRC for error detection, right? CRC. And it was designed to be implemented in hardware. However, the entire PPP is not in hardware, it's in the driver. So you are using software to do CRC calculation. So the overhead will be higher. Fortunately, PPP does not require high speed. It's used for SOHO, home users. So the bandwidth is not that big. So doing that extra error detection is not a big deal. Okay. And as you can see that in the PPP driver is divided into several components. I mean, from TTY device driver to PPP channel driver to PPP generic layer. Okay. And each layer would handle different things. So for these two layers, they do this. Okay. They handle this channel driver handle encapsulation and framing. Okay, but the generic layer handles compression, multi-link, some other issues here. Okay, and then so it's below the IP layer. Okay, and within the driver, and there's a daemon, PPP daemon here, in the user plane. These are in the kernel space. These are all in the kernel space. But here it's in the user space, the PPP daemon. And that daemon is to configure something. You need to use the daemon to configure the parameters. So it's not in the data plane, it's in the control plane. The PPP daemon is not in the data plane. So it only handles the control plane packets. Okay, if you expand, you will see that the PPP driver implementation is complicated because it needs to handle these parameters, negotiation of these parameters. So it needs to handle all this and all this. So that's why it's getting a little bit complicated. Okay, for the outgoing flow and incoming flow. And in this open source implementation, we expand that to describe the procedure, what they are doing. But actually, we don't get into the detail of these operation about negotiating the parameter and how these parameters change the data plane behaviors. We don't go into the detail here. Just let you know, okay, they need to handle these jobs.